Alright, time for another DraftPhysics.com, DebatePhysics.com also, video presentation. So we have an Action Lab video. I probably should do a playlist of the Action Lab videos. So another response that will not be responded to, so we won't get our counter argument of any kind. And that's all disappointing, but it's the way of the world. So he's doing an analysis of a Newton's cradle, and unfortunately he doesn't do the essential experiment, which is the free momentum experiment. The fact that if you change the masses that are interacting, that you do not in any way conserve kinetic energy, and you do have to conserve momentum, and you have to conserve it as absolute momentum. That is, you can't have 100 momentum in the universe and then an action happens and now you have 200 momentum in the universe, or 300 in the case of their theory. So I just have 100 going this way. Somehow I have an interaction that doesn't create more energy, and yet it produces more energy, because now I end up with 200 momentum going that way. I start with 100, I have 200, and I have 100 going that way. And they say that somehow I didn't need energy to do that. I didn't need gunpowder. I didn't need any force to explode. I didn't need any source of extra motion. I just have free extra motion. And it's the core of their physics. This is a 350-year-old theory, kinetic energy. They have an equation. It started with just mv squared. Now it's 1/2 mv squared, but that's it. And they have this notion that things have real extra energy by being smaller and faster, and being slow and heavy. No, that doesn't help you at all. That degrades your energy. And it's just physically wrong. It's not physics. It's incorrect. And so anyway, he's going to say some things about how energy is transferred, momentum is transferred. So I'll try to be careful in how I use the words energy and momentum. But I mean, frankly, I can't, it's hard for me to even imagine how momentum can't be energy. It does work. It has to be energy. It's ridiculous for me to think to play with the vocabulary the way they insist to play with it. I cannot imagine kinetic energy as a reality, and I can only imagine momentum as being the possession of a capacity to move matter. But anyway, so yeah, let's play it. It's easily debunked as being wrong. His analysis is just plain wrong, and the sad truth is he could have taken it to this level. He uses the word kinetic energy, but he doesn't make any claims about kinetic energy. And frankly, physics makes a ton of claims about kinetic energy. They claim it's real. All right.
What if I told you almost every explanation of Newton's cradle you've heard is wrong?
All right, so every explanation I've heard, is that basically it's a transfer of the energy from the one object at the end, just transfers it. So if I have just two balls, then it's just a transfer between the two, because that's all there are. And the fact is that the energy just moves through all the extra balls I put in the way. It just moves through them at the speed of sound in the medium that the sound is moving through, which is steel. So it's about 5 or 6 times faster. So you're talking about it, say, 5,000 miles an hour. The force travels through objects. And the fact is, when it gets to the last object keeps it. It's just about that simple. They're just arrows inside of something. Something has a disproportion of arrows. Again, we know that relatively speaking, this object could have less arrows and those objects have more. It doesn't matter who's really moving. We just have a difference in the arrows of motion in the two objects, and that difference will be resolved by just a conversion. The most arrows wins. The arrows just keep going. It's just a simple explanation. The extra arrows apply a force, and if the force is accepted, they keep going that way. And if they're rejected, then they go the other way.
Let me show you why. You lift one ball, release it, and then watch in awe.
So, okay, watch in awe, that's kind of mush. And obviously you do see this little extra movement, so it's not perfect in how this is conveyed. So the more balls you have, the more likely there's going to be some interference, some degrade of the quality of the sound signal that's being transferred, and so now it's going to move erratically, so it's not going to be as clean as one-on-one.
As the last ball on the opposite side swings away, seemingly transferring its energy perfectly to the last ball.
And it is seemingly transferring its energy, not perfectly, but 98%-y kind of way, quite efficiently, let's just say.
But there's something almost everyone gets wrong about this toy. Almost every explanation you'll find online tells you the same thing. This works because of the conservation of momentum.
Okay, and that's just part of the story. Everything works because of the conservation of momentum. So everything has to conserve momentum. And as I keep stating, momentum always gets right answer. So if you just use momentum, I don't think you can do any analysis where you'll get an answer where your bridge will fall down or your spaceship will do something silly. So if you just calculate momentum and equal and opposite reactions, you're not going to run into any trouble. So this is another case where it's implied that there's some better theory, like Einstein's better theory of bent space, when no, in the real world, all the Newtonian stuff works perfectly. And this is just nonsense, that there's some need for a better theory. No, there isn't.
For example, if one ball is released, one ball will come out the other end, conserving momentum.
And
there's only that much force. So all you have is the force that went in, 100. There's no other force. So that's it. That's all you've got. That's the motion of matter. And the total motion of matter after the hit is going to be the same. You can't make more matter move, more MV. So you can make little pieces fly off and go very fast, or you can make big pieces fly off and go very slow, but you can't change because every elemental bit is made out of these atoms, and the atoms are made out of electrons and protons. And the only thing really moving are the electrons and protons. And they all have the same mass. They collect force evenly. So there's really not an argument about what you're really exchanging. You're just exchanging force pushing electrons and protons. And all you can do is, if you have 1 million electrons being moved at some velocity, that's all you can exchange is the velocity of 1 million electrons.
on the surface, this makes sense, right? Momentum is always conserved. So if you lift one ball, it'll strike the others, and voila, the last ball flies off with the same momentum. So it's constant.
So it's obviously flies off with a little less, but you know, that's a technical detail.
Conservation of momentum that makes the last ball fly off instead of making the others move, right? Now I've added a tiny piece of plastic in between two of the balls.
And all
it doesn't
this does,
change the.
Oh shit! Unfortunate. Did it change? Yeah, it did. It changed the video on me. Oh, I hate these buttons. All right, so we're at the adding a tiny piece of plastic, and all the tiny piece of plastic is going to do is now completely change that speed equation. So now we're not going to get movement at the speed of sound in steel. We're going to get a whole different amount of pressure being applied to the first ball that the energy encounters, and it's all going to be now over a huge amount of time. So you're taking an event that's not very helpful. You're taking an event that has this straight up and down peak, okay, in a tiny amount of time, and you're converting it now into this stretched out kind of event. And that's why it can't just move through all the balls, get to the last ball, and it's all there at the same time. Now you've changed all the arrows, and a bunch of them are going slow, some of them are going fast. And so now the timing of the momentum's pulse is now completely made a mess of. And so now it's not going to be able to transition. It's not going to be interpreted because now you've essentially encrypted okay, the message, and the balls can't see the message anymore. It's not that the momentum isn't there. It's just that now the momentum is going to be collected differently by each ball because there's a different amount traveling through each ball.
Stick in between two of the balls. It doesn't change the mass significantly, but it'll likely absorb some of the impact, maybe making the last ball not pop off so high. But let's see what happens.
So that wouldn't be my conclusion. So my conclusion would be, oh, you've totally dissipated and changed how the energy is going to go into this, and so now it's just going to push the others. So I would have predicted correctly. There. So all you're doing now is that you're not transferring the energy as one coherent amount of energy. It's stuck in each one of the balls because it's now moving at a different speed. And you're likely the ball is going to move in the opposite direction. Let's see.
So instead of one ball popping off the end with all the momentum, all of the balls move as one mass together. In this case, momentum is still conserved because momentum is mass times velocity. So we start with a large velocity and a small mass, and this gets converted to a small velocity with a large mass.
Right, and the theory is, so that's the funny part, right? Because this is basically the drawing of the one mass hitting the three mass. He's claiming that's a conservation of momentum, but we know from the experiment that that's what it won't be. That the big mass is going to have more momentum than the little mass had to start with. That's their theory. That's what they claim is the truth. And then if I make this instead of 3 times bigger, it's 6 times bigger. Well, it's 6 times bigger. It's actually going to be 200. So the 100 hits, 200 comes out in the same direction the 100 was going. And then they think the little ball would reflect with 100. Now that doesn't obviously happen. So there's no rebound, no equal and opposite reaction or anything like that.
So momentum was still conserved in this case as well, but it didn't make the end ball pop off. So something else is going on.
So, there's no evidence he actually tested any of this to find out if the momentum actually was conserved and the 6 balls actually did move at the appropriate speed for the huge increase in the mass. But it certainly looks that way.
Going on here in Newton's cradle. To see what's happening here, let's start with just 2 balls. Imagine we have 2 balls of equal mass. One strikes the other. Now we have...
Yes, and what is imagined to have happen is one of them has this thing, this difference, and the difference is going to be interpreted when they collide, and all that's going to happen is whoever has the difference is going to be exchanged. So just like with friction, if you have motion, or it doesn't matter whether I move the sandpaper or I move the piece of wood. All right, that's the argument, that the friction is going to be the same either way. And so all you're doing is measuring how much you exchange. And all you can do is exchange the difference. So the one ball gives what it has, the other ball gives what it has. And so you end up just exchanging your condition.
I have 2 key principles that should tell us what's going to happen to the velocities of these balls after the collision. First, the conservation of momentum. The momentum of ball 1 plus...
So this is just, this is just such trivial and useless ways of understanding it, but fine.
Ball 2 before the collision will equal the momentum after the collision.
Yeah, and it won't... You know you can't make more movements. You just know that whatever the difference is the movement. You can't make more of it.
And the second is the conservation of energy. The total kinetic energy before the collision will equal the total kinetic energy after the collision.
Yeah, well, go ahead.
So that means the only unknowns are the...
So there's no point in saying this kinetic energy thing because we have one mass of the same mass, and yes, when it's the same mass, you're just saying garbage in, garbage out. So fake number of joules of energy in, fake number of joules of energy out. And it's only when you transfer between different amounts of mass that all of a sudden you're not going to have the same amount on both sides of the equation. You're going to either create free energy, free kinetic energy, or you're going to lose kinetic energy.
Velocities of both balls after the collision. We can solve for these, and what we get is that ball 1 will come to a stop and ball 2 will move off with the same velocity that ball 1 had before the impact. This is the classic Newton's cradle explanation.
And it's not an explanation, it's just an absolute fact that that's what happens. So again, it's not an explanation of how it happens, it's an explanation of what actually is observed.
And it works, but only for two.
It's true. It's not that it works, because it's not an explanation. So again, it's just nonsense to say we figured out that you have to conserve momentum, and yes, you do conserve momentum. It doesn't explain why you conserve momentum or how you conserve momentum.
Balls. What happens when we add a third ball?
It depends on when you add it, obviously. So if you add it when the balls are moving against, then you're going to have that appearance. And if you add it when the balls are going with you, you're going to have a completely different appearance. You'll end up with a nice oscillating system still, because you wouldn't have broken the oscillator.
Now we still only have two equations, but now we have three unknowns with the added velocity of the third.
So that was sort of a big cheat, right? That he does the experiment one way, doesn't do it very well, and implies that somehow it's all chaos, when it's not chaos at all.
Ball. When you have two equations with three unknowns, it becomes unsolvable.
Right, and so the equations are useless because, but you could do the observations and then you don't have unknowns. So it's just kind of pointless to talk about unknowns. You haven't put anything into any values in here at all. So the fact is if you do know these velocities, then you do have all the information you need, okay, to explain what you would expect to happen. So if I know the velocities and then I know the masses, I know what possibilities there are. Now, yeah, there's a lot of different ways I could do it if I change those total velocity numbers, but I can't change that momentum will always work.
There are infinitely many possible answers, yet the Newton...
So there really isn't. It just depends on you understanding what motion you have in them at the time they will collide. And so all you need to know is where they will be when they hit each other, how fast will they be going, and once you have those numbers, you'll know what's going to happen when they come out of the interaction. Because nothing extra can come out of the interaction.
Cradle seems to always know what to do, no matter how many balls we drop. Now you might try to break it up and imagine each collision happening one by one. So the momentum from this ball gets transferred to this one, to this one, to this one.
But that's the actual truth, is that if I hit a piece of steel, it's already been proven by that Alpha Phoenix guy, frankly, that you hit the steel and it moves, the energy moves at the speed of sound through the object, and it expands at the other end after it travels through the steel, and that's what happens. So it works. That theory is a perfectly valid explanation. The energy moves through the objects at the speed of sound, the pressure wave, whatever you want to call it, and when the pressure wave isn't obstructed, that is, there's no next ball to stop the ball from moving, it flies off because it's free to. There's an open place it can go. The energy is saying, yes, we can keep going this way because nothing's impinging against our motion. There's no reflection. There's no obstacle. So the last ball flies away because there's no ball in front of it. The simple explanation.
One to this one, to this one, and then the end pops off. But that would only work if all the balls had a separation between them.
No, it wouldn't. It would work if they're all connected. The more they're connected, the more perfect the transmission of the sound. If you want to transmit sound, you can't transmit sound if they're not connected. So obviously Newton's cradles does have the balls stuck to each other. It doesn't have them separated, because the more it separates them, the more there's all this nuance of the change in the speed. We're now changing the speed by sending it through the motion of the ball itself again, and it just makes it more complicated. I mean, it still works, but it doesn't work as well. But it still obviously conserves momentum. I mean, the more contact there is, obviously the more sound, the more changes in direction, because none of that's perfect. You're just making all the variables that do exist that detract from the experiment being perpetual, all of those variables are only enhanced by more interactions.
In real life, all the balls in the cradle are in contact with each other. So momentum transfers almost instantaneously.
So it doesn't. So that's just absolutely wrong. It's nowhere close to instantaneous. It takes real time. And so if you did this with a real slow motion camera and all that stuff, there's real time between the point where the ball hits and the other ball leaves. It's not instantaneous, and it's at a real kind of slow speed compared to the speed of light. It's an incredibly slow speed. Even compared to electricity, it's an incredibly slow speed.
So trying to separate these into individual collisions isn't correct.
So it isn't individual collisions, it's just transfers, because they're connected to each other. So just like sound transfers when objects are touching, the sound won't transfer if the balls weren't touching. So I could tap on one ball and I could hear it at the other end if the balls are touching each other. If they're not touching each other, I'm not going to hear the sound from one ball, and it's not going to transfer. It is going through the atmosphere. It's going to completely steal all the energy as friction.
As Nikola Tesla once said,
Oh, that's a bad start right there. A bad statement. He said a lot of 90% of what he said was crazy. Well, it's more than 90%, frankly. What do they say? Like any idiot can be right, 1% of the time.
if you want to find the secrets of the universe, think in terms of energy, frequency, and vibration.
Right, and all of those things are fine, but you have to understand what energy is. So I don't know what energy was for Nikola Tesla, whether he was an MV squared fan or a momentum fan, because frankly, it makes a giant difference.
So let's think of Newton's cradle in terms of vibrations. The metal balls might look like they aren't deforming when they strike each other.
So again, this deformation thing isn't in any way we were going to see, and the experiment works better the harder the steel. So hardened steel will take out a huge amount of losses to any kind of deformation. It's because obviously we know that steel doesn't deform in a flexible way, and the only thing that's going to deform in a flexible way is the electron pressure. So the atoms will elastically, like rubber bands, they'll move and move back. But the steel itself isn't going to be, if you deform it, you've used the energy and you're not going to transform it. You're not going to transfer it. So if you dent the balls, that's a loss of that energy.
But on the microscopic level, they're compressing, just like a spring.
So on the so it's more than that. It's more than microscopic. It's on the elemental level of electrons and protons. They're compressing. Okay, they're the elastic element.
So each ball is acting like a spring with a mass attached.
So not entirely. So again, so it's not entirely true, but yes, it will work. Okay, as a way of looking at it. But which spring is being compressed? So I mean, it has a spring attached to the first ball. The spring on the first ball isn't really isn't playing, because that ball is the one that's going to, just like you in gravity, it's going to push first. The Earth is going to push back. Gravity's not going to push back. The Earth is.
Attached to it. What's beneficial about this way of thinking is that we now have an equation that relates the force on each sphere to the displacement of each sphere.
So I'm saying that this is all crap, frankly. So it's one way of analyzing it, but you could do exactly the same thing with momentum, as long as you know the velocities.
So that means that we can now solve a set of differential equations to tell us exactly what each ball will do. And what we find is...
And you could have done exactly the same thing, because the information you have to have for that equation isn't any different than the information you need for momentum. There's absolutely no difference. And he's just pretending that because we're going to do this differential equation with the actual numbers, that somehow we couldn't do the same equation with the actual numbers if we use momentum. So he's just cheating the argument.
Exactly what you would predict. If you send one ball in from the front end, the last ball will pop off, not some different combination of moving spheres.
Sun chips? Forgot how good those are.
But there is a different combination, frankly. I mean, it's not as perfectly efficient as the idealization. Like none of these experiments is. I did play the commercial. It looks like it's still here, saying the math to get to this, but I don't know why her face is on here.
Point can be confusing. So let me show you what happens without math. And before we continue, I'd like to tell you about our sponsor, BetterHelp.
All right, so that's really disappointing. It's just so bad. All right, so he's back at the experiment.
Get the same professionalism and quality.
Oh no, we're not yet done with the silly commercial. It's disgusting, really. It's sad and pitiful. 10% off the first month. I mean, it's just terrible. It goes on for a full 5 minutes or something. Yuck.
Let's get back to our experiment. When the spheres initially collide, there's a shock wave or a compression wave that starts moving through the line of spheres in both directions. So
this is the part, frankly, that I should have just played, and I shouldn't even have bothered with the rest of the video, because it's all just, you know, a lot of stuff that we don't disagree with or disagree about in terms of its actual function. But this is his description of what's causing the effect, and it's just plain wrong, and it could be proven wrong by a very simple experiment. All right, so he's illustrating that some force wave goes both ways when there's contact, and it doesn't. It only goes one way. All right, there's no back this way. There's no force arrows going that way. The extra arrows are just going in one direction. All right, so continuing.
Shock wave that moves to the left reflects and starts moving to the right. And the shock wave that moved to the right eventually reflects and moves to the left.
And their timing would be sequential because the ball's the same size, so it bent across the ball and back, and that's exactly what's going to do at the other end. He's going to claim. So as it goes across, he's going to claim that it's going to go all the way to this end and for some reason bounce off that end. And my argument would be, why would it bounce off that end? There's nothing there to stop it. So now the force will just take that ball with it, because the force is perfectly comfortable. It's at the right speed to push all of the electrons exactly like the previous ball. That's what the wave is the actual force moving through the electrons, the pressure wave. And this pressure wave is completely unopposed, and so it has no reason to reflect, and it just says, we're going. So I'll let him continue the point.
Finally, the two waves meet, and when that happens,
So he's saying it reflects off the end of the ball for no reason, comes back, and then two forces repel each other. That somehow the force that went that way and bounced off the end of this one, right, for no reason again. Why would the force bounce? There's no ball there. There's nothing in its way. Why wouldn't the force just push the ball? So he's saying, no, it bounces and goes back, and now it's going to bounce and go back, and now there'll be two forces running into each other, and the two forces will somehow push the both things apart. And the two forces, even though they're going in opposite directions, only one ball will fly off. And no. So let him finish it, and then I'll explain how you can understand it can't be right.
colliding waves force the two balls apart at exactly the contact point, but on the opposite side. So it's almost like
So that's not what happens.
the time reversal of the initial collision.
So it's no time reversal, and that's not what happens. Okay, so I'll just draw over this what really happens. It's really quite simply proven. So if I redid the experiment, all right, so ball, you can see that. Yeah, put it lower. There's always something. All right, ball. Okay. And so the claim is that somehow this ball was going to come in, and I'm going to end up with a force going this way that's going to come back this way, and I'm going to have a force going this way, and that the two forces will be out of alignment, a full wavelength of difference between them, and that somehow one of them will bounce off this side, and that the two arrows will be opposing each other here. Now, the simple experiment you could do is prove, okay, to prove this is nonsense, is take the steel ball, and instead of making a steel ball, just change the shape of it. So make it a steel rod that's exactly the same weight, okay? And now you don't have the same timing through the material. At the speed of sound, this is going to take a long time to reflect off this end. And the fact is, it's not going to matter. Whatever this momentum is, that's what this ball will leave. So as long as this is just as hard a steel as this is, and you can change its shape, and so now you don't have any consistency in terms of the timing, and it'll still work perfectly. So that sort of proves the point that there's no reflection going over here and then coming back again, because I can change the time of that reflection by changing the shape of the ball, and it's not going to matter. Again, I could turn the weight into a giant piece going this way. It just doesn't matter what shape I make it. I can make it much quicker to have that reflection, and it's not going to change the fact that when it contacts, all that's going to matter is this MV, and that MV is going to travel right through there because it's the same mass and the same velocity, so the pressure wave will be perfectly consistent going right through all the metal, and it'll come out at the other end. So there's no reflection. And the obvious argument I'm making is that you can just sort of understand it intuitively, okay, without much thinking, that the only reason why the other balls don't move is because there's a ball in front of them. So this one feels the pressure, and there's a ball here, so it can't move. There's something in the way that it has to give energy to before it's going to move out of its way. And what is it going to use to give that energy? Well, the only thing it can use is the pressure it has. So it can give it the pressure, and now it doesn't have it anymore, and it can't move. So it's stuck. And then this one just transfers the pressure, and this one just transfers the pressure. That's all you can do, is transfer the pressure in the direction the pressure is going. And the fact is the thing can't leave until there's nothing in front of it to stop it from leaving. If there's something in front of it, then it's not moving. If there's nothing in front of it, it can move. That's simple. So the disappointment is the key experiment, the experiment he needs to do, somebody with a high-speed camera needs to do with a nice quality Newton's Cradle, or frankly a quality experiment of some other kind. Like I said, the lever thing is something that needs to be done too. But the simple experiment is colliding with an actual mass that, say, is 6 and a 1. And their theory basically says that I can put the 1 in with 100 momentums. You can almost see that. All right. And I'll get 200 here. And then I'll get another 100 back here. So I'll be able to do the whole experiment all over again. And the catch is that when these two things meet, they're saying that 100 momentum collides with 200 momentum, and only 100 momentum pops out of the collision. And I'm obviously arguing that's nonsense. If two cars crashed into each other with 100 momentum and 200 momentum, and they bent fenders, they're going to bend 300 momentum worth of fenders. They're not going to bend 100 momentum worth of fenders. So we know the energy's really there, and there's no way that you can elastically hit and then send this off with only 1/3 of the total momentum. That's not going to happen in reality. So we don't have that experiment, unfortunately, in enough done well enough or precise enough to draw any conclusions. They haven't, like I said, they haven't crashed any cars. They really haven't dropped objects. They haven't done any of these mechanical experiments to tease the truth out about what really works, momentum or kinetic energy. Now, we did land on the moon, and they had to use thrusters to do it, and they had to calculate how much energy they were going to get from the thrust they threw out of the spaceship. And I would argue that it only worked because they used momentum formulas, not kinetic energy formulas. And then you can have the ballistic pendulum as an example, where there's no experiment with catching bullets where they ever catch more than 0.06% of the bullet's energy, kinetic energy. They collect almost all of its momentum, but only 0.06% of its kinetic energy. Kind of a dramatic demonstration that It isn't real energy. That's why you can't collect it. You can't transfer it, and you can't make it do work. 5 times the force, okay, does not make something move with 25 times the energy. And certainly something moving 5 times as fast doesn't do 25 times the work. These are all just fables. They've never done the experiments. They never put a tug of war with a 5 mass going 10 velocity and a 10 mass going 5 velocity and proven that the 5 mass has twice the energy. None of it. And it's it's junk science just because they never even cared to collect any evidence. They just told us it's a truth, never thought they had to prove it.
The same thing happens with however many balls you start with. If I start with 2 spheres, then the collision happens further in. But the pressure wave moves through just like...
So again, if I just change the shape of the 2 mass, it still works. So it has nothing to do, as long as it's made out of the same material. So it just doesn't matter. There's no the pressure wave does not go in the opposite direction of the element in the experiment that has what appears to be the higher momentum.
And the 2 waves end up colliding 2 spheres in, exactly mirroring the initial collision. That means that if you mess up the speed of the wave propagation, then it'll change how the whole system reacts.
So that's what he just said. And obviously I can mess up the speed not by changing the material, that's silly, but just by changing the shape of the material, I have to change the speed because I'm changing the distance the pressure wave has to move.
So when I stuck some plastic in between, I slowed down the wave significantly.
All right, so you didn't slow down the wave, you changed the wave into a lot of different waves, a lot of different amounts of pressure. You start off with a little bit of pressure, a little higher, a little higher, a little higher, a little lower, a little lower. So you completely changed how the sound is going to be conveyed into the objects and made a bunch of noise instead of sound.
Significantly on one side. So the Newton's cradle didn't act like it normally does. What's neat is...
So they just made that part up, that the wave went all the way to the end, came all the way back, and then that ball waited, sat there and just waited for the 2 waves to hit each other for no good reason. This wave went back and forth real quick. This wave went all the way over here, all the way back, and somehow they met together again. No, they didn't. It didn't happen.
That using this piece of plastic, you can get the separation to occur wherever you put that piece of plastic. If I lift one ball...
Right, so it's the same thing as changing the mass of the object. As soon as you change the fact that all the electrons have a velocity, they're going to convey their velocity to the electrons in the next object. So if I change the velocity and now the electrons are moving fast and some are moving slow, then obviously I'm not going to have a consistent pressure wave. It's not going to be one wave moving through the object anymore. It's going to be a bunch of little waves moving at all different speeds. And that will not be able to reach the end and create a consistent motion.
Have the plastic in between balls 2 and 3, then that's where it separates, or any other spot you put it. If we explain it in terms of these pressure waves, there are reflections that happen anytime it goes from metal to plastic. So this causes there to be a separation point wherever the plastic piece is located.
So there is no real evidence that there's much reflection. So again, that's just him saying so.
Whether it's 2 balls or 5 balls, the wave propagation is what makes the last balls pop off in the exact order they do. But here's the thing.
So that's actually true. So it is this wave propagation. But again, the wave can be understood as you've just changed the pressure of the electron. So it's a change in the electron pressure that's moving. Nothing else is moving. You've pushed electrons. The electrons are pushing on each other, so it can be understood just like electricity. Except it's moving at a much slower speed because it's the pressure wave includes the whole atoms doing the motion.
Even a traditional Newton's cradle doesn't behave exactly as the equations predict. The materials aren't perfect, the balls aren't perfect, they're not perfectly spaced between each other, and the elasticity isn't flawless.
Well, it is pretty flawless. You can make it pretty flawless. So again, that's sort of a fake argument. So you can make it very well, or you can make it very cheap. So that's just sort of a bullshit argument. You certainly can reduce the influence of the variables.
In fact, researchers have found that when you start with one ball in a 5-ball Newton's cradle, all the balls have movement after the first impact. In a 5-ball Newton's cradle, balls 1, 2, and 3 move backward, while balls 4 and 5...
So, and the amount they move backwards is just infinitesimally small. And that's part of just the inefficiency of the contact. They're all not just touching each other quite enough.
5 move forward, with ball 4 carrying about 12% of the initial momentum. And
the trick is it depends on how heavy these actually are. So the heavier you make them, the less this is a problem. So he's using these different lightweight toy kind of Newton's cradles, but if he uses a heavier one, he'll get less and less of that effect.
Ball 5 carrying almost all the rest. What's crazy about all of this is scientists are still working to better understand this simple toy.
Bullshit. So that's just bullshit. They're not doing anything useful. The simple experiment is the free momentum experiment. It's so obvious. It's glaring right in front of your face. They claim 100 in, 200 keeps going this way. So I only put a 100 in, 200 is going in the same direction, and then 100 is going to bounce back. I mean, it's just absolute nonsense. If I'm getting back all my energy, it's going back up in gravity. So now I'm starting with exactly the energy I started with, and I have something already moving at 200. And so you can understand, you know, I can make this simple free energy device. I don't have to do any work at all. I mean, it's and again, there's no counter argument for this. There's no way to explain how, no, that's not what our theory would imply. Of course it is. So I could just make a device. Okay, I have a little ramp. These little steel balls are going to keep rolling down the ramp. And I have this pendulum, okay, I have it with a ball on it. And I'm just going to hit these balls with the pendulum. And so the balls are, this ball is a 1 mass, and these are, say, a 10 mass. Doesn't matter what we use, as long as it's much heavier. And the theory is that, I put 100 in here. It hits this ball, it leaves with 200 momentum. So it's going slower because it's 10 times heavier. It's going 1/10 the speed, but it has 200 units of momentum. So it's increased its capacity to move matter. All right, and I'm going to get my full 100 back, theoretically. I mean, ideally. And we know we're not going to get these idealizations, but I'm just saying if I could do this in space and take away all the variables, the fact is it should perfectly work. And even if I make it not work perfectly, that is, it comes back with only 90, you can still understand that, okay, I'm going to get 170 out. And then the next time I'm going to get 150 and 100 and then 80 and then 70. So I've gotten out in terms of motion going this way, momentum, mass moving this way. I can get 10 times what I put in. Easy. And like I said, if I can get rid of the silly variables that are consuming some of the friction, I can have a perpetual motion machine that just keeps making free energy. That's what their theory says is possible. That's what they say it can do. And obviously it can't do this. This can't happen. It can't possibly be true. And yet I have to make this argument for years to what are supposed to be intelligent, honest people. I mean, an honest person should say, yeah, I get what you're saying. It's going to be 200, and then, yeah, I got all my energy back because I used gravity. So gravity gave me all the energy back. I start with exactly what I started with in terms of lifted energy. I have the same capacity, potential energy. And, yeah, why not? I can just hit another ball. I can hit another ball. I can hit another ball. I can use the same energy to shoot the cannonball over and over again. So imagine a cannon where you never had to refuel it. You just do it once, okay, give it the energy, and it just keeps doing it over and over and over and over, and you never have to do any work. You never have to supply more energy. It just keeps refiring the cannon. I mean, too silly. And yet I got to argue this for years. It's just a commentary that humans are anti their own intelligence. They're hostile to this thing called logic, reasoning, honesty, integrity, all of these things you need to be able to do this communication thing in any kind of coherent way. They are hostile to that process. Somehow. They have the asshole gene, okay, and somehow I don't have it. Somehow my immune system wiped the virus out, the stupid fucker virus. I don't have it. So I can look at the facts and see the obvious truth that 300-year-old nonsense about some sort of v squared function is just that 300-year-old nonsense invented by a guy who was fanatically religious, which taints it from its origin, and who never did an experiment to prove it, by the way. Just had no experimental evidence, just claimed 4 pounds dropped 1 foot is the same as 1 pound dropped 4 feet, even though 1 pound dropped 4 feet is only going twice the velocity, and therefore can't possibly have the same momentum. But this is the nature of things. And on the internet, these people won't respond to any of these arguments. So it doesn't matter. You make a nice video, you make the argument. They don't care because it's just about supporting the religious institution. Support your Catholic Church. And that's all this is. This is a church of crap. Okay, and they call it science, but it's just crap.
For example, here's the concluding paragraph from a research paper looking into a more precise model of Newton's cradle. They say, we've shown that the physics involved in Newton's cradle is far from trivial, and that the standard text...
So it is trivial, and the standard text is really close to the truth, because the standard text basically says the motion travels at the speed of sound in the substance. That is the conventional theory. If you ask most physicists, I think that's the answer you get, is that the motion essentially travels at the speed of sound in the material. And that's what does frickin' happen.
This book explanation is only a first approximation. Students should see that apparently simple experiments, when closely examined...
So this is lovely text, and it's clearly not what any of this science is doing. So it's just such a joke. Go examine the presumptions of our science. We should do, experiments are great. We should find these details. And they don't do it anywhere. And they don't even do it in this case, where obviously the important experiment is change the masses and see what happens to the momentum. Because by their theory, the momentum goes all kinds of south.
Can raise a number of complicated questions. One also should be cautious about fully accepting well-established explanations of physical phenomena.
Isn't that a joke? Well, that's all they do. They just keep defending dogma, okay? We proved that, light is a wave because we did this double slit experiment, where we took 4 surfaces and basically made 2 of the surfaces so close together they couldn't possibly make. We made 2 single slit experiments that couldn't possibly create a fringe pattern. Because there's no wavelength of difference from the 2 points. You can't make a wavelength of difference, so there can't possibly be a fringe pattern. So you have no fringe pattern and no fringe pattern. And you get a fringe pattern now because now you have 2 sources again. But the real experiment with the real pattern, with the real envelope, with the real results is this experiment. And if you do this experiment, they can't explain it. They have no explanation for the double maxima. They have no explanation for the 2 patterns superimposed on each other because their theory is rubbish. 2 openings in water does not produce the same pattern as 2 openings in light. The only way they make the 2 look like each other is in the light experiment. They do this. They didn't do that in the water experiment. They did it in the light experiment.
Without carefully scrutinizing the arguments. So at first glance...
So again, no scrutiny, no anything. These people don't argue about anything. They don't really in any way examine the assumptions that's built into all their gibberish.
Newton's cradle might seem like a straightforward toy, but it's actually a window into a much deeper and richer understanding of physics.
Right, and you haven't really opened that window. You have this, do you have the technology to do the experiment correctly? Do you have this high-speed cameras? You have all this stuff, and you don't bother.
So next time you see one of these things on a desk, take a moment and think about the hidden waves of energy that are making it all happen.
Right, the fake ones you just described, the ones that actually don't function and don't actually mathematically work, and all I have to do is change the masses a little and you can be proven. But you didn't do that experiment.
And thanks for watching another episode of the Action Lab. I hope you enjoyed it.
Yeah, another pile of dogmatic crap from the religious kook. So it's just disappointing. Finish this up.
If you did, don't forget to hit that subscribe button, and we'll see you next time.
Fuck. It's just so disappointing. These people are just so obnoxiously arrogant. And they, again, and I can't provoke them into making an argument. I can't pay them enough. I mean, their price tags are outrageous, you know, $10,000. That's best I can get out of them. I asked them to just tell me, what do you honestly need to be paid, all right, to pay attention to this subject? They won't give me the number. So obviously in the past couple of years, I have offered as much as $4,000 to people like Thunderfoot and Veritasium and, you know, a few others. Even back in the physics girl days, I offered her $2,000. And they won't touch the subject. All right. So till the next time and such, so forth and whatnot. The evidence is it's a religion, an unaccountable, unwilling to discuss anything religion.